It's a pretty old IIBMT question. The question is like this. A 600 kilogram rocket is set vertical firing. Its exhaust speed is given for you. Mass of the gas ejected per second to supply the thrust needed to overcome the weight is how much is the question. So let's very simple question actually. Let's try to understand what he is saying. This rocket has to move forward upward. How it moves upward? By ejecting some gases downward. Now he is saying how much of the mass of the gas has to be ejected per second. Mass of the gas ejected per second, so that rocket moves up with a velocity of exhaust speed of 1000 meter per second, whereas the mass of the rocket at that instant is 600 kilogram, right? So it's very clear that you need a force in upward direction only to compensate the force in downward direction. Force in downward direction is weight itself. Force in upward direction can be written like rate of change of momentum. Rate of change of momentum, in the place of momentum I can write mv equal to weight equal to mg. Here this this m is the mass of the gas that is varying. This m is the mass of the rocket. Please don't cancel both of them. Here it is very clear that velocity that he want attained is fixed, constant. Mass is exhausting up, burning up per second. So this mass is variable. So I can rewrite that equation as V into dm by dt. You need the force only to overcome the weight. You don't want any extra acceleration in the problem. This V is given to you as 1000. dm by dt you are asked to find out. Mass of the rocket is given 600. Assume G as G. So 1000 equal to dm by dt, 1000 into dm by dt equal to 6000. So the mass of the gas ejected per second dm by dt is 6000 by 1000, that is 6 kilogram per second. So that rocket has to eject a mass of this way 6 kilogram per second, so that it can move upward with a velocity of 1000 meter per second. It's a simple Newton law of motion, second law, and there is nothing complicated to worry about. The only thing that you need to understand little carefully is every time F is not ma, rather F is also equal to V dm by dt. This is possible only when velocity of the body is constant and mass is varying. If mass is constant, velocity is varying, obviously we write F equal to ma. Of course, that's how we solve this problem. Thank you for watching.